Hello, our students. Our lesson today, Unit 4, Lesson 4, Parallelism. Relation between pairs of angles formed from two parallel straight lines and transversal to them. In the opposite figure, the two parallel straight lines L and M, the straight line N intersects them, then is called transversal. So, the straight line L is called transversal to the two parallel lines L and M. In this case, we get 8 angles formed from this intersection. And these 8 angles could be classified according to their position relative to the transversal as follows: alternate angle, corresponding angles, interior angles on the same side of the transversal. Now we will represent each pair of the previous pair of angles. Number 1, alternate angle. Alternate angles are identified using as letter Z. If a straight line intersects two parallel straight lines, then each two alternate angles are equal in measure. For example, if the straight line AB parallel with the straight line CD and MN is a transversal to them, then measure of angle 4 equal to the measure of angle 6 as alternate angle. This is the letter Z. Measure of angle 4 and measure of angle 6. And the next figure, measure of angle 3 equal to measure of angle 5 as alternate angle, and this is also letter Z. So this is the alternate angles. The alternate angles are equal in measure. Don't forget it. Alternate angle are equal in measure. Number 2, corresponding angles. Corresponding angles are identified using as letter F. If a straight line intersects two parallel straight lines, then each two corresponding angles are equal in measure. For example, if AB is the straight line parallel with the straight line CD and MN is transversal to them, then measure of angle 1 equal to the measure of angle 5 as corresponding angles. Measure of angle 2 equal to measure of angle 6 as corresponding angle. And also from the previous example, here I have another two corresponding angle. Measure of angle 4 equal to measure of angle 8, this is letter F. And measure of angle 3 equal to the measure of angle 7. Thus are called corresponding angles. Number 3, interior angles on the same side of transversal are supplementary. And we can identify it using letter U. If a straight line intersects two parallel straight lines, then each two interior angles on the same sides of the transversal are supplementary. It means equals 180 degrees. Okay, for example, if the straight line AB parallel to the straight line CD and MN is the transversal to them, Then measure of angle 4 plus measure of angle 5 equals to 180 degrees as supplementary. Measure of angle 3 plus measure of angle 6 equals to 180 degrees as supplementary. So as all these angles are called interior angles in the same size of the transversal are supplementary. Don't forget it. Example number 1. In the opposite figure, find the value of x. Since AB parallels CD and CA is a transversal, then measure of angle CAB plus measure of angle C equals to 180 degree, interior angles and supplementary. Then 80 degree plus 2x equals to 180 equals to 2x equal 180 minus 80 degree. Take 80 degree to another side with the opposite sign. 2x equals to 100 degree, then x equal 100 degree divided to, then the value of x equals to 50 degree. Exercise number 2. In the opposite figure, find the value of x. Solution. Since AB parallel with CD and CL is transversal, then measure of angle BAL equal to the measure of angle C as corresponding angles. Now we can replace measure of angle BAL by 2x equal to measure of angle C equal 80 degree, and solving is an equation. So 2 we can put it in the next side by division. So x equals to 80 divided 2, then x equal 40 degree. Then the value of x equal 40 degrees. Exercise number 3. In the opposite figure, find the value of x. Solution. Since BA parallel with CD and BC is transversal, then measure of angle B equals to measure of angle C as alternate angles. Then 3x, or we can replace measure of angle B by 3x and measure of angle C by 60 degree and solving it as equation. So x equal 60 degree divided 3, then the value of x equal 20 degrees. Exercise number 4. In the opposite figure, ZX parallel with LM and LZ parallel with MY, measure of angle Z equals 60 degree. Find the measure of angle L, find measure of angle M. Solution. Since ZX parallel to LM and ZL is transversal, then measure of angle Z equals to measure of angle L equals to 60 degree as alternate angle. This is number 1. Then we will find measure of angle M. So since LZ parallel with MY and here LM is transversal, so measure of angle L plus measure of angle M equals to 180. Then measure of angle M equals 180 minus 60 degree equals to 120 degree. It's interior angles and supplementary. Exercise number 5. In the opposite figure, EF parallel with DA and DE parallel with BC, measure of angle E equals 72 degrees. Find measure of angle CBA. Solution: since EF parallel with DA and ED is transversal of them, then measure of angle E equals to measure of angle D equals 72 degrees as alternate angle. And since DE parallel with BC and DA is transversal of them, then measure of angle EDB equals to measure of angle CBA equals to 72 degrees as corresponding angle. So the measure of angle CBA equals to 70 degrees. Exercise number 6. In the opposite figure, AB parallel with CD parallel with EF, measure of angle A equal 45 degrees, measure of angle E equal 130 degrees, find measure of angle ACE. Solution: since AB parallel with CD and AC is transversal of it, then measure of angle A equals to measure of angle ACD equals to 45 degrees as alternate angles. Since CD parallel with EF and CE is transversal of them, then measure of angle DCE plus measure of angle CEF equals to 180 degrees. So measure of angle DCE equal 180 minus 130 equals to 50 degrees as interior angles and supplementary. But here I want the angle ACE, all the angle. So the angle ACE equal angle ACD plus angle DCE. So measure angle ACE equals 45 degrees plus 50 degrees equal 95 degrees. Exercise number 7. In the opposite figure, AD parallel with CE, measure of angle B equals how many degrees? Hence, draw a line passing through B and parallel to AD and CE at this. I draw the line BM. Solution: since AD parallel with BM and AB is transversal of them, then measure of angle A plus measure of angle ABM equals to 180 degrees supplementary angle, interior angle and supplementary. Then measure of angle ABM equal 180 degree minus 130 equals to 50 degrees interior angles and supplementary. And also since BM parallel with CE and BC is transversal of them, then measure of angle MBC plus measure of angle ECB equals to 180 degree. Then measure of angle MBC equal 180 minus 150 equal to 30 degrees at interior angles and supplementary. But here I want all measure of angle B. So measure of angle B equals measure of angle CBM plus measure of angle ABM. So measure of angle B equal 50 degree plus 30 degree equals to 80 degree. Exercise number 8. In each of the following figures, show why AB as a straight line is parallel to straight line CD. Since AE is bisect to the angle BAC, I look to the figure and I see here AE is bisect to the angle BAC. Then measure of angle BAE equals to the measure of angle EAC, which is equal to 29 degrees. So all the angle A, measure of angle BAC equals to 29 plus 29 equals to 58 degrees. And now we can deduce that this is angle A equals to 58 and angle C also equals 58. So measure of angle BAC equals to measure of angle DCA as alternate angles. Then AB is equals to the straight line CD. Exercise number 2 here. Since AE is bisect to the angle BAC, then measure of angle BAE equal to the measure of angle EAC, which is equal 56 degrees. Now measure of angle BAC, all this angle equal 56 plus 56 is equals to 112 degrees. So measure of angle BAC plus measure of angle DCA, which is equal 112 plus 68 equal 180 degree, interior angles and supplementary. Then AB is a straight line parallel to CD is a straight line. Now you have 2 examples as a homework. Please do that with yourself in your home. And at the end, thanks for your listening.